Hello, folks. Welcome to Rational Science. We have a great day today. I'm going to be covering several subjects. The main course will be Mr. Tyson, Neil Tyson, and a lot of you know him. And no, this is not about racism. This is not about politics or anything like that. This has to do with science and whether Mr. Tyson is a scientist or whether he's a pseudoscientist, whether he sells pseudoscience out there, especially to black kids who look up to him, and follow him thinking, this great celebrity out there. No problem with celebrity. The problem is whether he's selling science, real science. And we'll find out today. Anyways, that's going to be the main course. A little later, we're going to start with a little bit something else. Last week I talked about the LHC shutting down. That was good news. We have more good news today, so bear with me. We have good news. It turns out the Chinese are also shutting down their collider. They've made this big collider called a CEPC, whatever it's called, right? And the issue is that that one it was supposed to be the biggest collider in the world, 100 kilometers long. CERN's, in comparison to the LHC, is 27 kilometers long. So you can see it's almost 4 times as much. It would cost $5.1 billion to complete it. They started in 2012, but the Chinese government, the Communist Party, I guess, right, did not include it in its 5-year plan going from 26 to 30. They cut it off as red ink, I guess. And so now the only one that remains, and that's also, I guess, still wishful thinking, it's the European Future Circular Collider. Whether they're going to approve the money for that or not, who knows? It's going to supposedly be constructed sometime in the 2030s. And, I hope it doesn't. It's just a waste of money. Okay. So, all these people who contribute money, your tax dollars, because you have accelerators in the States, the Fermi Lab, SLAC, so Stanford Linear Accelerator, you have Brookhaven. There are accelerators, and what are they doing? They're just wasting money, salaries, high salaries for a lot of these so-called physicists, okay? And so, yeah, we have a problem with all that money. Anyways, I hope everybody's listening to me, hearing me properly. Let me know otherwise. Let's move on to the next subject. We have a fellow who complained that I don't know the difference between gravity waves and gravitational waves. Okay, and so he says the following. Says, you keep using the term gravity waves and gravitational waves as if they are interchangeable. They are not. They are two completely different phenomena. And I put a question mark there, and you say, well, why did you put a question mark, Bill? The issue is these people don't know how to talk. They don't know. I mean, if you're going to spend 1 second of your life to put a comment, okay, have the decency or have the presence of mind to put your version. You have people who come here and say, Bill, I don't like your definition of ether. I don't agree with it or whatever. Well, don't tell me that. Tell me what you think the ether is. That way we can have, if you're going to have a discussion, let's have a discussion. If you're just going to bitch about the fact that I did not use your definition, you're not saying anything. So I don't know why these people even bother to put a comment. They're wasting their time. And the answer to this fellow is, yeah, gravity waves and gravitational waves are exactly the same. There's no difference whatsoever, okay? And Mr. Tyson's going to confirm that later for me. Turns out that he does the job for me. But here it is. This is what the R2D2 tells us, the AI. It says gravity waves and gravitational waves are not the same. Gravity waves are common disturbances in fluids, right? Where gravity is the restoring force. And what are gravitational waves? Ripples in space-time itself. Okay, now what's the difference? The key distinction is that gravity waves are in a medium. Oh, I love that one, because that's in a medium. But they say that gravitational waves are disturbances in space-time, meaning, right, implying that space-time is not a medium. Okay, this is what the AI tells us. AIs are programmed by the establishment. So here you have kind of like a contradiction, because you see the two at the bottom, they're both illustrated in the same way. In fact, Mr. Tyson's later on going to confirm that gravity waves and gravitational waves are exactly the same thing. So people think that they're talking about something different. No. The idea is very simple. You throw the stone in the pond and you have all these ripples, the waves coming out of there. That's exactly what they're talking about, both for gravity waves as well as gravitational waves supposedly propagating through space-time. Okay, so we're done. If you find any difference, please let me know. Okay, and here one person puts the modern physics, you can call it physics, mathematical physics. In other words, a religion, right? He puts it in the right context. He says the following. He says, modern science has abandoned the pursuit of truth for the comfort of prediction. Here's the problem. We've gotten sloppy with language. Absolutely. That's essentially what the problem is today. They don't have language. They have this mathematical language, and it's based on words such as field and energy and mass and time. None of those words have anything to do with physics. And you say, Bill, you must have misspoken. No, I didn't misspeak. Those words have to do with math. They are words that represent mathematical concepts. And mathematical concepts can only describe. Science, physics is about explaining. Math cannot explain. Math cannot tell you what exists out there, let alone explain how the universe works, meaning why it works the way it does, because for that you would need to identify the invisible, intangible objects that Mother Nature uses. That's why math is not the language of physics, has nothing to do with physics. Anyways, and it's destroying our ability to think clearly, absolutely. We call everything that waves a wave. Water, sound, light, crowds, doing the la-ola, right? But wave is a verb describing behavior, not a noun naming a thing. That's the problem. They don't have things in mathematical physics. They don't have a single thing. And you cannot do physics without things. You need objects to, mimic or simulate the universe, right? You need objects. And these people are doing it with concepts. They're moving, the mass in this direction. They're vibrating the fields, and they're transferring the energy, and all those are concepts. Those are mathematical concepts. They're transferring numbers, values, magnitudes. That's what they're doing. That's not science. That's not physics. That's irrationality. Water waves sound propagate in a wave-like manner. These are completely different substances that share a behavior. You can slay down a mountain, but you don't become a sleigh. This matters because linguistic precision enables conceptual precision, enables ontological precision. Think of it like a football match. Bayern versus Manchester City. Final score 3-2. Now imagine no one knows who scored. I could theorize Haaland got a hat trick. You could theorize that keeper scored all goals. Both theories predict the same scoreboard, but only one is true. In other words, matches Mother Nature, right? What actually happened. That's modern physics. Einstein and Newton both predict the same observations, but one says gravity is a force, the other says it's not a force at all, which is not really true, because Einstein is saying that this is the explanation they give. This is the mechanism. This is the, how they explain gravity. They say that mass, which is a concept, weighs down number lines known as length, width, and height plus time, whatever that is. They say it's a four-dimensional canvas. You could call it a fishnet. Not true. It's a mathematical concept. You have a mathematical concept weighing down another mathematical concept, and this is how they illustrate it as the bending of number lines. So and you require a force, because why does mass go down? That's what you got to ask yourself. So we have a problem with mass pushing downwards. Why doesn't it pull downward? Why don't they do it in reverse? That's what they should be doing so that people get the hang of it. And he completes that. He says, both can't be true about what reality actually is. Yet physicists shrug and say the math works. That's not science. That's scoreboard watching. Science should tell us what is actually there, not just what numbers will measure. Linguistic and ontological precision isn't optional. It's the whole point. Okay, so yeah, I commend this fellow. He kind of summarized exactly what's going on in mathematical physics, the fact that we don't have any explanations. Not a single mathematical physicist on Earth in the last 10,000 years, even going back all the way to the Greeks if you want, right? I can tell you why this pencil falls downwards. Something as simple as that. They cannot tell you why a pencil, here's a spoon, repeatable experiment, goes down. No one can tell you why this falls down. And if you think that it's caused by warped space, the bending of the canvas there of the number lines, well, you're wrong. First of all, that's a concept. You don't bend number lines. That's one issue. That destroys the whole theory. But there's something just as bad, and that's that Einstein said you can only use his equations out there in the macro world. You cannot use it here in the comfort of your house, of your home. Okay, his theory is only for macro world, and so you cannot explain with Einstein's field equation why the spoon falls downwards. Okay, so we don't have an explanation, a mechanism from the mathematical establishment of why a spoon falls to the floor, and that gives you a pretty good ruling on how important, how successful mathematical physics has been. They cannot explain gravity. They never will. They cannot explain it with numbers. They cannot explain it with equations. They can't run an experiment to prove to you what caused it. So I ran an experiment just now. Well, so now explain it. That's the issue. Okay, and mathematical science, physics has gone off the rails completely for the last 100 years since they invented quantum mechanics and relativity. And here's just a sample, okay? This is just a little straw from the entire haystack, right? Here, scientists produced a particle of light that simultaneously accessed 37 different dimensions. I call them dementia. That's what I call it, dementia, because that's what it is. And there you have 37 dementia. And string theory, got up to 26 dementia, then they went back down to 11, 10, whatever. So these are the dementia. This is what's out there. This is what they teach out there. This is what they propagate among the population. And so if you think this is science, no, this is not science. This is total garbage, poppycock, irrationality. And that's what they're giving the public as proven truth. We proved it. We have evidence. We have the equation. What is that? What is all this dementia that's out there? And this is a good way of, ending this part of the discussion. Here we have Mr. Calhoun, and he'll tell you where we're at today. Like I say, we're the last generation of humans on Earth. And here, Mr. John Calhoun, who ran experiments with rats and mice, he'll tell it to you in his own words what the mathematical establishment is really like. Listen to him.
The mouse universe simulated the present situation of a continually expanding population of humans. Young mice growing into adulthood exhibited an even different type of behavior, the beautiful ones. Their time was devoted solely to grooming, eating, and sleeping. They never involved themselves with others, engaged in sex, nor would they fight. All appeared as a beautiful exhibit of the species, with healthy, well-kept bodies. These mice looked inquisitive. They were, in fact, very stupid.
Sounds like our world today? Sounds like mathematical physics? You bet. Okay, let's move on to the main course. And we have this gentleman. His name is Neil deGrasse Tyson. Who is he? What does he do? Well, he's an Einstein imitator. He's a follower of Einstein, and that's why I put the proper hair on him, okay, because he really vouches for Einstein. Okay, no problem. So you vouch for Einstein. We have two issues here. First, whether Einstein was a scientist, whether he was a physicist, or he was a pseudo scientist, right? That's one issue. And then the other issue is whether Mr. Tyson himself, is he a scientist? Is he a, physicist? Let's find out. Let's begin with Einstein, and here is a very quick, important, the key points of Einstein's bio. Okay, he put out 4 papers in 1905 known as Annus Mirabilis. I'll call it the miraculous anus because he was really lucky to put out those papers. He put out these 4 papers. He got the 1921 Nobel Prize for the photoelectric effect, the first one there. He never got it for relativity at all. He was never recognized for it. But the important one is that one there, special relativity. Okay, that's the important one. That's the one that will make him famous, not the other 3, right? Somewhat. The last one is also E equals mc squared, but he wasn't the first one to really come up with that. There were other ideas running around, and that's one of the issues you should keep in mind. But special relativity, why is that important? Well, he's most famous for relativity, right? And one of the problems there is that, he didn't come up with most of the ideas that today are ascribed to him. They're saying that he came up with all these notions, that he mathematized, that he came up with new ideas. Well, it's wrong, and wrong on all of them. Okay, so let's find out really quick here. Here's Valdemar Voigt, and he's the guy who came up with the most important part of special relativity, which is that equation there, 1 minus v squared over c squared. You have the velocity of the object over the velocity of light squared, both, right? And that's the one that's going to give you the whole thing for special relativity. So if we're going to talk about equations, that was the key equation or key factor. Lorentz is going to use the what you see under the modern notation. He's going to use and I guess claim it as his because that's who it's attributed to today, to Lorentz. In fact, here's the Lorentz factor. Okay, you can see it here. He's the guy who essentially came up with special relativity together with Poincaré. Okay, and so they came up with this nonsense about time dilation and length contraction and all this other nonsense that they came up with today, and that today is just passed around to the new generation. All the new generation has to do or can do is just memorize what these folks came up with. You go to college, and it's what they teach you, and you're a freshman, you don't know much, you're a little bit naive, you're in there, and they immediately bombard you with Einstein and relativity and general relativity, special relativity, and there's this course material that you got to swallow, and you got to memorize it to pass the test on Friday and whatever, and also at the end of the year. And the smart people say, well, I think this is all nonsense, and I don't. I think I'm not understanding. I'm not made for this, and they drop out. Those are the intelligent ones. They go into engineering or architecture, or who knows what. And the guys who stay, because it's a sifting mechanism where only the dumb ones stay and say, well, no, I'm going to continue. This sounds very interesting, blah, blah, blah. And it turns out these are the people who eventually graduate, right? And they get jobs. And they get jobs only because one of the two, they may not believe in the stuff, but they have to play along because they studied all these years and they need a job. And so the only way they're going to get a job is if they bow down to Einstein, So they have to keep on with the, like the emperor's clothes. They have to say, oh, the emperor does have beautiful clothes there. Yeah. And the emperor is completely nude. So, Einstein did not come up with length contraction. In fact, here you have a couple of the guys who did, okay? One of them is Oliver Heaviside. He, 1888, Einstein was 9 years old, and he's the first to propose an equation, the idea that electromagnetic forces shorten in the direction of travel, okay? And one of the things Heaviside said, which is I thought was interesting to mention, mathematics is an experimental science, and definitions do not come first, but later on. So he invented or at least a proponent of, operational definitions. You give your entire presentation, and at the end of it, you tell the crowd what you meant by that word. This is the way he reasoned. That they make themselves when the nature of the subject has developed itself. And he really got this a little bit from this other fellow. His name was Galileo, and Galileo said something similar in the 17th century. He says, mathematics is the language in which God has written the universe. And believe me, if I were again beginning my studies, I should follow the advice of Plato and start with mathematics. And another thing that Galileo said, he said, you need experiments. He said, I think that in the discussion of natural problems, we ought to begin not with scriptures. Remember in those days, the Catholic Church was very important, very powerful. So he said, maybe we should not harp so much on the Bible and religion. Maybe we should do some experiments and, figure out what they tell us, right? And so this is what he vouched for, pretty much like Oliver Heaviside, a couple centuries later. And then he contradicts himself because he said something which I like, which is where the senses fail us, reason must step in. Why is that important? Well, because we cannot see the mediators of gravity, of light, of magnetism. And so he says, the senses fail us. Yeah, our senses will fail us there because these are invisible, intangible mediators. And what has to step in? Reason must step in. And he used that notion in his book, Dialogue Concerning Two New Sciences, where he said, even without further experiment, it is possible to prove clearly by means of a short and conclusive argument that a heavier body does not move more rapidly than a lighter one. He was talking about, gravity, the fact that, heavy objects fall at the same rate as lighter ones. And so you don't need to really run an experiment. You should be able to do it by reasoning alone. And that's something that's missing completely in mathematical physics. People who believe that, you have to do everything through experiment and equations. Absolutely not true. Okay? Anyways, George Fitzgerald came later. He talked to Oliver Heaviside about a year later when Einstein was only 10 years old. And pretty much here's a summary. After discussing with Heaviside, writes a letter to Science in an attempt to explain the ether null results of the Michelson-Morley experiments. Objects are foreshortened in the direction of their motion. Okay? So you can see that these are the fellows who really came up with all this stuff and not Einstein. Einstein comes a little later when he's a little older, and he didn't wear any short pants anymore. He didn't drive his bicycle. Maybe he rode the streetcar by then. Okay. So this is where he's at. But the issue is that, why is Einstein so famous then? I mean, if he did not come up with a lot of this stuff, why is he famous? Why is he a household word? Everybody essentially uses the word Einstein as a synonym of intelligence. Says, oh, he's an Einstein, like, oh, Jesus, he thinks a lot, or he's got a great brain or whatever. Is that true for Einstein? And here's a summary of how Einstein made it to the top, okay? First of all, Hermann Minkowski, I got to mention him. He was Einstein's teacher. He was the first to describe space-time as a four-dimensional space, okay? And in 1908, he said, henceforth, space by itself. This was in a, I think he was in a conference and he gave this speech, right? Henceforth, space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality. He's the guy who created space-time, not Einstein, okay? Then what happened? During the war lasted from 1914 to 1918, okay? In 1917, the British were still in charge of territories like Iraq and so on down there in the Middle East. And so, they approached the Jewish lobby, which had a lot of money, a lot of influence. And Balfour, who was a British foreign secretary, he sent the letter to a Jewish leader by the name of Lord Rothschild. And a lot of people know who he is, right? He was a rich man, promising national home for Jews in Palestine in exchange for support during the war. Okay, and that's when the issue started, when Jews started going into the Middle East. Then what happened? In 1919, and by the way, Einstein was Jewish. He was a German Jew, right? 1919, British Arthur Eddington makes German Einstein. Here you have a British guy making, elevating a German, but not just any German, a German Jew. That's important, right? Famous right after the war, confirming Einstein's warped space-time theory that light bends around the sun. So not only was there a reason for Eddington to do that, but also, this was there was a political reason in the background for all this as well, because of the context. By 1920, you have people, two Nobel Prizes, in fact, Leonard and Stark, and both of them, they started raving and ranting about Jewish physics. They said, especially referring to Einstein, and said, "Oh, it's all that Jewish physics." And they would harp on that even further when Bohr comes around, because his mother was Jewish, and he had to, get out of Europe in the days of Hitler. And so this lasted for 20 years, at least 20, 25 years. And Stark is going to be the fellow who is going to be in charge of physics in Germany under Hitler. So you can imagine, there's a lot of politics behind it. Einstein leaves Europe and eventually ends up in the United States in Princeton. He wins the Nobel Prize in 1921, again, only because of the photoelectric effect, not because of relativity. And so that, in a nutshell, gives you an idea why Einstein was promoted by many people who were around him, many organizations and so on. In fact, he was offered the presidency of Israel. As I understand it, they didn't want him to accept it in secret, and Einstein decided not to accept it. But, again, a lot of that is politics, and that's how these people become famous. And some of that is behind people like Neil Tyson and some of these other people like, Brian Greene, and even before him, Carl Sagan. There's a bit of politics. There are organizations behind all these people pushing them along. And some of it is anti-religious. They're working against religion. They say, look, we got to stop all especially the ultra-right religious, the conservatives, and they say, we got to fight against them, and so we're going to do it through science. We're going to show them that science show that they're wrong. We're going to provide proof. Okay? And one of the things that they say Einstein did in his, we can say early years, not so early, in his middle years really, was that, thanks to Einstein, we got rid of the ether. And that's not true either. These are all misconceptions that people have out there. Here's Einstein in 1920 at the University of Leiden, and he says, we may say that according to the general theory of relativity, space is endowed with physical qualities. In this sense, therefore, there exists an ether. According to the general theory of relativity, space without ether is unthinkable. Now, that's out of his mouth. I mean, this is ether in the theory of relativity. And you have to keep in mind that Einstein, to some degree, he was a realist. He thought that physics had to have some reality behind it. Unlike people like Bohr and Heisenberg, Born and so on, all these people, they did not believe, they were spiritualists. They did not believe that the universe is made of matter. The stuff out there, like stars, planets, and so on. Eventually, they came to believe, because of their experiments, that what underlies it all is motion. Motion makes objects. And so we have a realist like Einstein who did not know how to explain why he had those ideas. He had just an intuition for it. but he never could come up with it. He never discovered it. He died in 1955 without understanding how this universe works. Why? Because he tried to do it with equations and based on, experiments. And we don't need any experiment. We don't need equations at all. Not to explain why this stupid spoon falls to the floor. We don't need any equations for that. We need to figure out what is in contact with the skin of the spoon. And Einstein never realized that you need objects. You need to figure out what mediators are here that we cannot see or touch. And Einstein never figured that out because he was, again, thinking that, I need some kind of equation, the master equation that will unify all the forces. No. What we needed was a physicist, someone who says, look, something is in contact with this, and that mediator, there's a physical mediator that we cannot see or touch. So no experiment will elucidate this property of Mother Nature, gravity, and no, not only no equation, no experiment, no equation. We don't need those to figure out how this universe works. A baby can understand it once you explain it to them how this universe works. You don't need to go to college. You don't need to go to high school. A 10-year-old can understand gravity, can understand how a magnet attracts another. We don't need high level, calculus or linear algebra or anything like that. Okay, but it turns out that Einstein, did not believe in a lot of stuff. And these are some things he did not believe in. Okay, he created some of the equations for these phenomena or theories, you could say, but he did not believe them. Okay, quantum mechanics is in its entirety. He cleaned his nose holes with it. Okay, he did not believe anything regarding quantum mechanics, specifically the Copenhagen, interpretation. Big Bang, black holes. Why? Because he did not believe in singularities, that they were real. He said, look, that's a mathematical concept, and you can't turn that into a physical object and say that a singularity inside a black hole is what moves a star far away around. You can mathematize it and describe it mathematically. Don't tell me that it's the physical cause of why a star goes around, orbits a center of some kind. And that's where the problem is today. These people are looking through their telescopes, and they're looking at effects. They're not looking at things because they cannot see the thing. So they, say they give assumption of what's out there, but they turn it into a proof and as evidence. They say, we proved it. We have evidence. We have the equation. And what they're talking about is mass. They're talking about kilograms. And kilograms are not physical objects. You cannot say a kilogram pulls on you. Okay, you cannot say the kilograms of the earth pull on you. Okay, and that's what they're doing with black holes. They're having concepts pulling on you. Wormholes, he came up with the equation together with Einstein, Podolsky, and Rosen, or I think it was only with Rosen in the case of wormholes. But the point is that, he came up with this equation, which you could say is an equation for action at a distance. But he did not believe that there is a line connecting, one particle on one side of the universe to another one over here. And same for entanglement, EPR, right? That's the one for Einstein, Podolsky, Rosen. A measurement of one system cannot instantly affect a distant one. What he called spooky action at a distance. God does not work in mysterious ways. Gravity waves, he did not believe him. He wrote, I talked about that last week, he wrote at least 3 papers. One I think was 1916, the other one 36, which he published in 37, and another one in 38 as a follow-up. And the last word from him was that he did not believe gravity waves existed or, were even a possibility. And of course, they shoved all that up his nose holes, and they said, look, we're going to make you the king of gravity waves. And today everybody mentions, that Einstein is the guy who came up with gravity waves. Yeah, he came up with them, but he did not believe in them. And he did not believe in tachyons because it went against his special relativity, which were the speed of light is the maximum speed, and here tachyons are faster than light. So they had a contradiction there. And you have all these people who today are researching tachyons and developing equations and who knows what for it. They're violating special relativity. It's like, they don't care. They just move on. And so this is the problem that, Einstein did not believe in a lot of this stuff. And he's being credited against his will. He's rolling in his tomb. He's saying, look, don't credit me with all this stuff. I had nothing to do with it. Or he did, in a sense. He created the monster, Frankenstein. That's why I like to say that it's a Frank Einstein. Frankenstein. And Frank Einstein, ran amok. He's a monster, just came out of the table, started running throughout the world. Okay, so, and I would think that, knowing how Einstein thunk, okay, I would say that he would not believe in any of these. He would not believe in quarks, gluons, Higgs field, dark matter, or dark energy. I think if you were around, that's what he would say. Again, it's because he was more or less a realist. But this is not what is taught at the universities. You go to the universities, they teach you something totally different. They teach you that Einstein did it all. Okay, and then look, he was such a genius because he came up with this, he came up with that. And they never tell you, or it's not reinforced, especially to the public, that he did not accept a lot of this stuff. And again, because he was trying to find, how this universe works, and he could not figure out through math or experiments, so he was in the dark. He was groping in the dark. Okay, so now we come to this fellow. His name is Neil Tyson. And Neil Tyson is a fanatic of Einstein. They all are, really. You have to, you have to bow down to good old Einstein if you want to get ahead in life. And this is a quick bio. He went through Harvard, University of Texas at Austin, where I used to go, Columbia, and Princeton. Okay, so he went through all these colleges, got a degree. Okay, I guess he became what is known as an astrophysicist. I don't know what that is. In science, there's only physics and non-physics. There's physics and philosophy. That's it. And there's no other category. All the others are subcategories. And this guy apparently is an astrophysicist, I guess, specializing just in the universe, whatever they do there, right? He's a science communicator, which I say that's not true. Teaches religion. That's what he passes on to the public, just religion, okay? Because all of what he has is irrational, okay? And because he, vouches for quantum mechanics, relativity, string theory probably. I don't think he knows much about string theory, but he does vouch for what he learned in college, which is quantum mechanics and general relativity. That's his catechism. That's what he learned. That's what he memorized, okay? And one of the problem I have with that is that, he never contributed anything, any novel concepts, any novel theories into science, okay? So, he should not be so famous in the sense of a scientist because he never contributed anything new, okay? And he's the director of the Hayden Planetarium. Okay, great. And of course, he's, has his talk show. And that's where he propagates his stuff, and that's how he makes his money. Now, he's a successful businessman. I think he doesn't understand a lot of the math that all these other people have developed today. In fact, whatever he learned in college, he forgot probably a lot of that math today. The only math he does today is arithmetic, and then he does it with his accounts in the bank. But I don't think he does calculus anymore or any of that stuff. He's busy with other stuff. So he's there as a figure, as the face of physics. But how much does he really understand? How much does he really know? How much does he still remember from college? Okay, and I guess Neil is not familiar with Einstein, whom he worships, because he doesn't understand that Einstein did not believe in all the stuff that he does. Okay, so Einstein did not believe in all this stuff, and that's what Neil believes in. So why he praises Einstein so much, I have no idea. Okay, so let's present some proof, evidence that Neil, has different ideas than Einstein. Here's one, okay, and again, all these are from his mouth. Okay, his horse's mouth. So listen to him. This is about time travel.
We can easily travel forward in time, and we've known how to do that since 1905. Einstein's special theory of relativity lays out the whole recipe of how you can move into the future. And all you have to do is go into sort of a lower gravity field relative to other people, or just travel very fast. And your clock will tick slower than that of everybody else that you've left behind. That's easy to do, and we've known how to do that. Traveling backwards, that's the problem.
Okay, so in 1905, they already knew how to travel to the future. And you can see that they were a little far behind. I don't know if Neil knows, how badly things were in 1905. They were still riding, bicycles and cars that were just being started, old-fashioned cars by today's standards. And this guy's talking about 1905. We already knew how to travel to the future. Jesus, that's interesting to know. Okay, Tyson also believes in wormholes. Listen to him. Okay, I'm not putting words in his mouth. These are all from him. Okay, listen to him.
So a wormhole, just so people can understand it. Imagine if you had a sheet. Our universe is now a sheet. So if I take that sheet, normally I'd have to travel the full length of the sheet to get from A to B. You warp the space and then open up a hole from one side to the other where the two places are close in this higher dimension. And if you warp it a lot, it can happen basically instantly, like walking through a doorway. Or if it's warped a little less, then it'll take you a little longer. But in all cases, your effective speed is way greater than the speed of light because you basically cheated and went across the other side.
Yeah, you got to cheat in mathematical physics. Cheating means that you're going to say something that is irrational. That's what cheating means. And the question is whether, he actually believes this, that it's possible to just circumvent the speed of light by, folding space-time and just walking across, just stepping across the threshold. Would Einstein believe in this? Well, obviously not. Einstein did not believe in wormholes, even though he's the creator of the wormhole, EPR, Einstein-Podolsky-Rosen. That's the EPR. That's the wormhole equation. And does this fellow really believe this? I mean, he goes to the university 10 years to come out believing that he can just walk across the threshold and he's already in another universe, in another time or whatever. And why not to the past? He says we can't go to the past, but why not? I mean, if we have this blocked universe, there should be no reason why you cannot go and shake hands with Napoleon. No problem. Gravity waves, we talked about that last week. Einstein did believe in them. He's the guy who came up with them. And again, he wrote 3 papers about them. Here's what Neil has to say about it.
Einstein predicts the existence of gravity waves. So, gravity waves were predicted to move at the speed of light in Einstein's equations. So what makes gravity waves? When gravity changes somewhere in the galaxy. So if you have 2 stars orbiting and then they collide, then there's a ripple in the gravitational wave continuum that's out there. And that's what you would then see. If a star plunges into a black hole, these are disturbances in the gravitational field. And those disturbances are the gravity waves that get measured.
What is a continuum? What is this continuum? Can I eat it? Can I kick it? Can I, bang it or something? There's no such thing as a continuum. Those are words invented by the mathematicians because they don't have objects. So they had to invent all these concepts and they work with concepts. And so what can I tell you? This guy really believes in all this nonsense. It turns out that Einstein did not believe in gravity waves. And he made that clear. He died in 1955 without believing in gravity waves. And so the question, and that was reinforced by Rosen, who wrote a paper with him. So the question is, why is Tyson vouching for Einstein if all his beliefs or the theories he's got in his mind are totally contrary to what Einstein believed in? And note that they don't clarify, no, none of them do, okay? None of the mathematical physicists clarify to the public, right, that Einstein did not believe in all that. Because, I mean, they should mention that. Say, well, he came up with the idea, but he didn't believe in it. Then at least people get the message. That never comes in there. You read article after article after article, and rarely do you read where it says that Einstein did not believe in singularities and Big Bang and gravity waves and all that nonsense, black holes and so on. They don't mention that because people might question, say, hold it, he came up with all this equation that he's so famous for, and he didn't believe in black holes? Einstein did not believe in black holes, huh? And he didn't believe in Big Bang, and gravity waves, which were proven by LIGO, you know. So people might start asking questions, and they don't want people asking questions. They say, look, just pray to Einstein, you'll be okay. You know, say your prayer every night. So what did Tyson say about gravity? I mean, Einstein is known primarily because of his input into gravity, what he proposed for gravity, warping of space-time. So what does Tyson have to say about this? Does he know what gravity is? Can he explain it now that he's been a follower of Einstein throughout all his school years and even today? Let's see what he has to say. Here goes.
I can describe what gravity is doing. I even have a mechanism for it. Gravity really is the curvature of space and time. Movement of matter on that fabric of space and time we call gravity. Why does matter and energy curve space and time? Okay, that's a frontier. We're still working on that.
Yeah, it's the whys where he has problems with. Mathematical physicists have no whys. They cannot explain. What they have are descriptions. And that's where he gets stuck. He said, look, you know, we have a mechanism for it. It's warping of space-time. Is that a mechanism? You're going to warp the number lines? Is that the mechanism that you propose for gravity? Is that why this spoon falls downwards? Because space is warped down here? Suddenly, you know, I mean, did it warp just now? Is that why it's falling right now? It's not warped here now, but, you know, after I put the spoon here, now suddenly it warps? Why does it come down? Why does it warp upwards? I mean, space-time is all over the universe, right? It is the universe, supposedly, right? So, yeah, they cannot explain. That's the big problem. They cannot explain. They cannot give you the whys. They have no answers for the whys. But here he says it much better. Here he goes. Listen to him. One more time here. On his program Star Talk, mathematical physicist Neil Tyson was asked, what is gravity? This is what he replied.
We can describe gravity. We can say what it does to other things. We can measure it, predict with it. But when you start asking, like, what it is, I don't know.
He don't know. He doesn't know. That's the problem. He doesn't know. See, they know everything. They tell you they've proven everything through experiments. They got the equations. You know, they get their Nobel Prizes. They go on the talk circuit, but they don't know. And they will never know. They will never know. I mean, how long have we been with gravity? Since the Neolithic? I mean, you know, look how hard this is, okay? Very difficult experiments. It's $1 billion experiment, so don't do it at home, okay? You take a spoon, you let go of it, and it falls downwards. No one in mathematical physics can tell you what causes, the why this happens. After so many years, after all that mathematical physics, after all those equations, after all the experiments, they cannot tell you. What's his answer? We don't know. And he says it's a frontier. No, it's not a frontier because nobody's investigating that. They consider that philosophy, ontology, metaphysics, word salad, as far as they're concerned. That's not part of what they call physics, mathematical physics. What they do is equations all day long, calculus, you know, long a bunch of factors and variables and so on. You know, that's what you're spending your tax dollars on, for these people to develop equations on stuff that doesn't exist, such as black holes, gravity waves, Big Bang, you know, all that good stuff. Dark matter lately, right? Okay, so if Einstein came back, I think this is what he would do with to with good old Neil. Would say, "Hey, you never learned much about gravity, did you?" So yeah, poor old Neil. You know, he doesn't know anything about anything. All he does is his job is just to be a figurehead, you know. And I don't have a problem with that so much. I mean, if you want to get an autograph, you go there and say, "Hey, I saw Neil Tyson the other day, I shook his hand. I got an autograph. You know, he's a celebrity. He's a Hollywood star. Yeah, no problem. No problem whatsoever." The problem is when you confuse him for a scientist. You know, you have all these kids out there, especially black kids, who look up to him because they say, "Oh, I want to be like Neil Tyson. I want to go to college, get a degree, and go." That part is good. But what's bad is thinking that he's a scientist, mistaking him for a physicist. That's where we have a problem with him. And yeah, so what can I tell you? You know, and here's another thing, you know, that shows you how ignorant Neil Tyson is. And it shows you that in all these years, you know, mathematical physics, which is what he learned by rote, by warming a chair, you know, at the university, never figured out what space is, okay? And this is a summary, you know, essentially this is what Neil believes in, or how he reasons it, you could say. A simple vacuum, what they call empty space. Nothing is what we might consider empty space in our daily lives, okay? But if you remove the air, right, then what do we have? Well, what we have is trace particles that are still in there that you cannot see. So we still do not have nothing. We do not have empty space, I guess you could say, right? Totally empty space. Then you have the quantum vacuum, which is what he learned by rote against in college. Empty space is not truly empty according to quantum physics. It is a dynamic field full of fluctuating energy and virtual particles that constantly pop in and out of existence. I think he's talking about souls, spirits, ghosts. What is he talking about? What do you mean in and out of existence? He just learned that phrase and that's what he puts out there? This means the vacuum of space still has physical properties and energy. Energy? What is energy? Energy is a concept. Hopefully there's no energy out there. Energy is only in your, you know, when you do your exam, you have to calculate something, you want to put value in any equation, then you use the word energy. But energy is not a thing that you have out there, okay? There's no physical object called energy. But if you believe otherwise, next time you come to the conference, we want you to bring a handful of energy and show us what you're talking about, okay? And then absence of space, time, and physics. He says the most profound level of nothing is a state prior to the Big Bang. This would be an absence of not just matter and energy, but also space, time, and the very laws, or the in-laws maybe, I don't know, of physics as we know them. The true nothingness is a concept that is beyond human conceptualization and may only be a theoretical idea. Okay, so this is the notion he's got. The way they do it in mathematical physics is they say, you want to know what space is, what nothing is, what vacuum is? No problem. Get a box, remove all the air. First there's nothing in the box, right? But there's still air in there. Okay, so you remove all the air. Let's not figure out how they did that. Don't worry about it. They say there's still particles in there. Okay, because you can't get rid of all the particles through vacuum. Okay, so let's remove all the particles. Now we have concepts in there. Now we have energy, virtual particles that pop in and out of existence. Let's remove those as well. Now we have the laws of physics in there. This is how they reason. You call it reasoning? Yeah, that's what they call it. Anyways, it turns out that, you go to other sites like Sabine Hossenfelder, and Sabine says more or less the same thing. She starts out, no visible objects, right? No air. Then you go to no radiation, right? Fields, that's still in there. No matter, remove all the particles, you still have something in there. No laws of physics. Now again, laws of physics. No mathematics, logic, right? Removing abstract structures, whatever those are, right? No God consciousness. We're going to remove all the spirits from heaven and hell, right? Okay. Then we have pure absence, a state before anything, including potential. And finally, the ultimate nothing. What is that? Beyond conception, a complete non-existence. Okay, so this is how they reason. This is what they're taught by rote. This is what they learn by rote. They're poets. They just go up there and recite poetry. You know, well, this is what I learned by rote. And they just recite, and they have all the cliches and all the phrases. You know, they master them pretty well. Where did Sabine get it from? Well, I don't know if she got it from here, but he says the same thing. This is Don Lincoln at Fermilab. I mean, respectable, right? Fermilab. How much more authority do you want than that? And he says everyday vacuum, because he works with vacuum over there, you know, the accelerators. Space with no visible objects, same thing. Then he goes into removing air molecules, right? Then he goes into neutrinos and dark matter, constantly passing through everything, including your body, right? Because they interact weakly with matter. So they don't make holes in your body like, you know, cheese, Swiss cheese, right? Then you have quantum foam. What is that? Well, that's all these virtual particles that come in and out of existence, whatever that is. What do you mean they come in and out of existence? By what physical process? And the issue there is that all they have is an equation. They need, you know, a fudge factor, and they call that a virtual particle whenever they need it. That's what a virtual particle is, just one that they create when they need it. Absence, the last one, no space-time or physical laws. Again, you know, when you remove everything from the box, what you still have in there are all those physical laws, okay? Because I guess you can touch them or whatever. What is this nonsense? What do you mean there's physical? All we had to do all these millions of years, right, is define the word space. That which has no shape. We're done. That's all they had to do. They don't have to go to the lab and start removing parts or things out of an empty box. They don't have to do that. Please don't do that anymore. Okay, they're all doing the same thing, and Neil Tyson's no exception. And here we have the bottom line. You know, again, this is Arvin Ash, and he's going to tell it to you in his own words that you have all these virtual particles forming all this background. We can't get rid of them. They pop in and out of existence, whatever that means. They annihilate each other, and then they create each other. You know, by what process? Here, listen to him.
In quantum physics, even the vacuum of space with no particles or radiation is still teeming with activity. These are quantum fluctuations where particles and their antiparticles spontaneously appear and annihilate each other constantly. This isn't just theory, it's been observed in experiments. Empty space is more like a bubbling soup of virtual particles popping in and out of existence.
I like it. He says they've been observed. You see why we remove the observer from science, from physics? There are no observers, no witnesses, there's no testimony, because these people want to introduce an observer. They say, this is what we observed in the lab. So you observed quantum particles coming in and out of existence in the lab. You observed them like, you know, 2 eyes. And what they're doing, they need a fudge factor in the equation. They say, we'll call it a virtual particle, which is a virtual value, not a virtual particle. There is no particle, but they need that value to make the equation come out right. So it's got nothing to do with observing, like, you know, with eyes, which is what the word observe indicates to normal humans out there, right? And they use the word observe, and then they say, well, observe means something different in our religion. Oh, okay, yeah, great. Okay, so let's find out if we can solve where the problem is. Here you have annihilation, okay? And what are we saying here? Well, mathematically, you can take minus 1.6 coulombs plus 1.6 coulomb, 10 to the minus 19, right? We don't care about that. But you can add one and subtract the other, and you get 0. So mathematically, you can say, okay, we had these 2 coulombs, these 2 charges. They came together, and they turned into 0 because one annihilated the other. You know, mathematically you could say, okay, I think I understand, you know, I have $1, I subtract $1, I get 0. Okay, we all understand that. What's happening is you have the positron, the electron, they come together and they annihilate. And this is a little more difficult to understand because they have these, they say that mass converts into energy. We have these kilograms converting into mega electron volts. Okay. And so the question here is, you know, are we doing physics or are we doing math? I mean, this, we can understand it from a mathematical point of view. Is this what's happening in reality? Is a particle disappearing from the universe wherever it goes? I mean, what's happening to it? Is it turning it into empty space, whatever empty space is? Because these people say empty space is a thing. So how, what did it turn into? And then you have also other properties such as color, charge. You have the red and the green. If they add up, can you get zero? If you get the green and the blue, can you get zero? If you get the red and the blue, do you get zero? I mean, how do you convert colors into what, zero, into black, white? What do you get in return? And they say, well, we're not talking about color. Oh, okay, it's just a property. It's just a value that they have. They put a 1 or 0 or whatever in there, and they're dealing with numbers. They're not dealing with colors. Okay, so this is the issue. But from a mathematical point of view, we can understand that if you have $1 and someone takes it away from you, you subtract $1 from a positive $1 minus $1, you get 0. We all understand that. That's got to do with math. That's got to do with accounting. Okay, that's got to do with an equal sign in between, two factors, right? But here we're talking about something else. We're talking about physics here. And here's the issue, okay? Let's see if you can see where the problem is. Here you have two particles, okay? They're coming together. And these people are saying that they turn into nothing. So what happened to the particles? I mean, are they, what do you mean annihilating? Are they turning into nothing? Two particles coming together? I would say that from a physical point of view, I would get something more like this, where you have two particles coming together and they form a gray ball. Because you got a black ball, a white ball, we'll consider them as antonyms, as opposites. And when they merge, you would think you get a bigger gray ball. That's a better theory, I think, than saying that they annihilate and become absolutely nothing. And then we have the same process in reverse where you have, empty space. And from empty space, you have these particles coming into being. What kind of nonsense is this? I mean, what do you mean two particles? How did they come in? By what process? What I need to know is the mechanism. Don't tell me that they do and that you did the math. Tell me what the mechanism is. But they don't do that. Okay, so this is where the problem really is. These people are saying that, two particles come together, turn into nothing. And then nothing somehow, for whatever reason, breaks up into two particles that come into being for a very short amount of time that they are not able to measure. But they see it in their calculations and they say, oh, we're going to call that a virtual particle. Came into existence, got out immediately before we could put the probe and measure it. That's the state of so-called physics today. That's what they've done with physics after 400 years of experiments and equations, math. We got to get rid of all these people. That's what I think we have to do.